The death of the scaling law. Training a model on an additional trillion tokens of web text now yields less than a 0.2% improvement on the abstraction and reasoning corpus. We have reached the point of diminishing returns, where raw compute can no longer compensate for structural flaws in autoregressive prediction. The data from early 2026 suggests that while models are getting more fluent, their ability to navigate complex logical constraints is functionally stalled. This plateau is forcing a move away from massive dense transformers toward a more calculated architecture known as the logic wall. The mechanism of stochastic failure. Standard transformers fail at reasoning because they are essentially playing a high-stakes game of Mad Libs. They predict the most probable next token based on statistical patterns, not logical necessity. If you ask a model to solve a Sudoku puzzle it has never seen, it often fills the grid with numbers that look plausible but violate the core constraints of the game. This happens because the model lacks a ground truth engine to verify its own work in real time. To solve this, researchers are now decoupling the creative generation from the logical verification, leading to the rise of System-to integration. How logic gating actually works. The core of the neuro-symbolic shift is the integration of satisfiability modulo theories solvers, or SMT solvers, directly into the inference pipeline. Think of it like a writer working with a hyperliteral editor. The LLM acts as the proposal engine, generating multiple potential reasoning paths in natural language. These paths are then translated into a formal symbolic language like Z3 and passed to a deterministic solver. If the solver detects a logical contradiction, it rejects the path and provides a specific error trace that forces the LLM to backtrack and try again. This creates a verifiable reasoning chain that is mathematically guaranteed to be consistent, which is how we achieve error-free outputs in technical domains. The hidden latency penalty. There is a massive trade-off here that the marketing teams are carefully avoiding in their press releases. Running a formal logic solver during inference is computationally expensive. Recent benchmarks show that a logic-gated model takes nearly 12 times longer to generate a response than a standard model of the same size. However, the efficiency gain is found in the parameter count. A 10 billion parameter model using symbolic verification now consistently outperforms a 1 trillion parameter dense model on formal logic encoding tasks. We are effectively trading raw generation speed for a massive reduction in hardware requirements and a total elimination of logical hallucinations. The shift from fluency to validity. The transition to neuro-symbolic architectures proves that the era of scaling laws was merely a temporary substitute for architectural precision. By offloading reasoning to deterministic symbolic solvers, we have effectively decoupled linguistic fluency from logical validity. This means that for builders and engineers, the skill set is shifting away from the trial and error of prompt engineering and toward the design of strict logical schemas. You will no longer be asking the model to be smart. You will be building the formal constraints that make it impossible for the model to be wrong. This changes the stack from a black box that we hope works into a modular system, where the LLM is just one component, in a verifiable pipeline. For those developing in highly regulated industries like medicine or aerospace, this is the only path forward that meets safety standards. Watch for the first production-grade logic-gated kernels to hit the open-source repositories by this November, as they will likely replace standard inference engines in enterprise applications. Subscribe for more